We're going to discuss direct variation today. Before we begin, let's go through a couple exercises. I want us to solve for the variable. So we have 5 equals 3 times x. So in order to solve for x, we would divide both sides by 3. So x would be 5 over 3. For this one, 4 equals 1/3 times k. If we wanted to solve for k, we would divide by 1/3, but remember we said that dividing is the same as multiplying by the reciprocal. So we could also say that we're going to multiply by 3 over 1, or multiply by 3. And if we multiply both sides by 3, we get k is equal to 12. Okay, now 3 over 5 equals y over 25. So for this one, we're going to multiply by 25. When we do that, 5 goes into 25 5 times, and then 5 times 3 is 15. So we get y is equal to 15. Now this one, 3 over 5 equals 25 over x. Now this time when we solve, we can solve it like a proportion. So we get 3x is equal to 5 times 25. So now we've got 125 divided by 3, and we get 41 2/3. All right. So my question for you is to ponder this. If 4 is equal to 6k, what is the value of 3k? Now 3k is half of 6k. So what is half of 4? Well, half of 4 is 2. So the value of 3k would be 2. So direct variation is formed by the variables x and y, and you're looking for a ratio. And remember, ratio is a fraction. So you're looking for y over x, y divided by x. And if y divided by x is always the same number, constant k, and k is a positive, then you have a direct variation. So let's look at what an example of that. We also say it's directly proportional. So variables are directly proportional when y is said to vary directly with x. So y divided by x is always the same number. And whenever you divide y over x and you keep getting that same number over and over and over again, that same number that you get over and over and over again is called k, constant k. And we call that k value, or that number that you always get, the constant of variation, or the constant of proportionality. It's called the same thing, so you'll need to know both terms. Let's go back. When we do y over x, 30 divided by 1 is 30, and 60 divided by 2 is 30, and 90 divided by 3 is 30, and 120 divided by 4 is 30. So we keep getting 30 every time we check our ratio. So we would say that this is a direct variation, and our constant of variation would be 30. So does y vary directly with x in the following table? If so, find the constant of variation and write the equation for the direct variation. So x over y, here we go. So when x is 1, y is 3. When x is 3, y is 9. When x is 5, y is 15. And when x is 7, y is 21. So remember, when we check to see if it's a direct variation, we're going to do y divided by x. So 3 divided by 1 is 3, and 9 divided by 3 is 3, and 15 divided by 5 is 3, and 21 divided by 7 is 3. So we kept getting 3 when we did the ratio y over x. So our answer would be yes, y does vary directly with x, and the constant of variation would be 3. So here we go. This is showing the work. We did y over x for each and every ordered pair, and every time we got the number 3. So our k value, our constant of variation, would be 3. And so the formula for the equation for our direct variation is always y equals k times x, or you have to solve for k. And since we know that k is 3, our equation for this direct variation will be y equals 3 times x, because 3 is our k value. All right, so constant of variation. It is a steady rate of change. It is a constant variation or the constant proportionality. So we want to indicate which equations represent a direct variation. And if it does give a direct variation, we want to give the constant. So f of x equals 2.2 times x. So this one would be a direct variation, and the k value is 2.2 because that's what's coming right before x. What about y equals 4x minus 1? Well, this one has the minus 1 on the end, so we would say no. This is not a direct variation. What about d equals 45 times t? This is a direct variation, and our k value is 45. What about y equals negative 2x? So this is a tricky question. This is actually not a direct variation, and it's because our k value has to be positive, and this is a negative 2. So since it's negative, it can't be a direct variation. So we learned our slope-intercept form last time. It was y equals mx plus b. And this time, we're learning the direct variation form, which is y equals k times x. Now, this y equals k times x, this is never an answer for us. This is just something to help us find the equation. So let's say we want to graph the direct variation y equals 4 times x. We can make a table and do -1, 0, 1, and get 3 ordered pairs to make our graph. So we're going to do x equals -1, and we get y equals -4. X equals 0, and y equals 0. X equals 1, and y equals 4. So now we have these 3 ordered pairs. We can go ahead and plot on our graph, and then we'll connect those dots, and we have graphed our direct variation. So this example says find k. So find k if y varies directly with x and y equals 12 when x equals 1/2. And then write an equation for the direct variation. So this is a 2-part question. Part 1 is find k. Part 2, once we find k, write the equation. So part 1, to find k, we're going to use the direct variation form, which is y equals k times x. We're going to use this to solve for k. Since we know that y is 12 when x is 1/2, we can plug in y equals 12 and x equals 1/2. And now we get 12 equals k times 1/2. And now we solve for k by multiplying by 2 on both sides. And so now we would say that k is equal to 24. So this is part 1. We found k. But we're not done. Now we need to write an equation for the direct variation. So remember, the equation is y equals k times x, where we have to say where k is. Well, we know that k is 24. So when we write our equation, we'll write y is equal to 24x. And that's our equation for the direct variation. Next example, if y varies directly with x and y equals 6 when x equals 2, find y when x is equal to 2/3. Well, this one is just one question. It says find y when x is equal to 2/3. But if we want to find y, we have to know what the equation is. And if we want to know what the equation is, we have to know what k is. So really, we're doing 3 problems. We're finding out what k is, then we're finding out what the equation is, and then we're going to find y when x is equal to 2/3. So we're going to use our handy-dandy y equals k times x to find k. And y is 6 when x is 2, so we'll say 6 is equal to k times 2, which means that k is equal to 3. Now we can use k equals 3 to write our equation. Y is equal to 3 times x. And now that we know what our equation is, we can find y when x is 2/3 by substituting 2/3 for x. And now we have y is equal to 3 times 2/3, which means y is equal to 2. Next example, find k if y varies directly with x and y equals 14 when x is equal to 4. So this one is just a one question problem, find k. So we're going to use our handy dandy y equals k times x, and then we're going to plug in x and y and solve for k. So we have 14 is equal to k times 4, which means that k is equal to 14 over 4, which reduces to 7 over 2, and 7 divided by 2 is 3.5. So we would say k is 3.5. Now let's find k if y varies directly with x and y equals 15 when x equals 2. So again, we're just solving for k, so we're going to use our handy dandy y equals k times x, and we're going to plug in 15 for y and 2 for x. So 15 is equal to k times 2, and when we solve for k, we get k is equal to 15 over 2, and then 15 over 2 is 7.5, so k is equal to 7.5. All right, so now we have the question, if y varies directly with x and y equals 7 when x equals 1, find y when x equals 6. So this is one of those three-part questions. Part 1, we had to find k. Part 2, we have to get our equation. And then part 3, we had to find y when x equals 6. So we're going to start with finding k. We're going to use our handy dandy y equals k times x. And they tell us that y equals 7 when x equals 1. So we're going to substitute 7 for y and 1 for x. So we have 7 equals k times 1, which means that k is equal to 7. So if k is equal to 7, our equation is y equals 7 times x. So now we can figure out what y is when x is 6. Y will be 7 times 6, so y will be 42. All right, next problem. If y varies directly with x and y equals 27 when x equals 15, find y when x equals 6. So this is one of those three-part questions where you have to find k first, then your equation, and then plug in your x to find your y. So we'll start with y equals k times x, and so we're going to plug in y equals 27 when x equals 15. So we get 27 equals k times 15. We'll solve for k, which is 27 over 15, which reduces to 9 over 5. So k is equal to 9 over 5, which means that we have the equation y is equal to 9 over 5 times x. And we want to find y when x is 6. So y will be equal to 9 over 5 times 6. But since we're doing fractions, we're going to say 6 over 1. So now y is equal to 9 times 6, which is 54, over 5 times 1, which is 5. So y is 54 over 5. All right, so in this example, we want to indicate which equations represent a direct variation. So if we have a direct variation, we want to give the constant of variation, the k. And if it's not a direct variation, we want to explain why it's not. So y equals 4 times x. So if you said that this was a direct variation, then you are correct. It is. And our k value would be 4. Now we have y equals 3x plus 5. If you said no, then you are correct. This is not a direct variation because we have a y-intercept, and it's supposed to be in the form y equals k times x with no plus b value. So since the y-intercept is not 0, then we don't have a direct variation. So the answer is no. Next one, y equals negative 4x. So this one's also not a direct variation because the number in front of the x is negative. It's not supposed to be negative. The slope has to be positive. So since we have a negative k value, then we say no, this is not a direct variation. All right, your turn. You're going to try 9.7, 2 through 6 evens. It's due in class with your notes.